Hello everyone, welcome to the new tutorial for the Biosensors and Bioinstrumentation Lab. What you can see on the screen is how changes look like when you look at the spectrum closer, and this is another way to assess the performance of your probe, and it is pretty intuitive one. I guess everyone working with sensors more than a month noticed that there are times when one and the same sensor performs well and then doesn't show sensitivity at all, or vice versa. And this tutorial is designed to help you understand if the sensor is really not sensitive or something just got wrong during calibration. So let's begin. Here I will present a real case study. Several months ago, I made a calibration stability study where I made several calibrations of the same sensor set. And results you can see in this file. You see, reproducibility is mostly decent, but sometimes just some calibrations are unlucky, and you can end up discarding a good probe which just had a bad day. I did not make any statistics on this, but you see that the chances are not zero, and it's better not to take chances in discarding a probe and without second consideration. We will focus on the story of the probe with codename LV30, which is the most dramatic one. As you can see, the first calibration was a mess, and I would have discarded this probe. But fortunately, it wasn't the calibration stability study and got rescued to show very good sensitivity afterwards. Now let's see the script, which can help you to avoid discarding good probe. And here you can see it. This is how it looks like. And you can find it in the folder on the desktop called Calibration Scripts. Its name is Micron Visual Inspection of Spectral Features. How you work with it? Let's go step by step. After you open it, you will see this section where you input your parameters for the data you want to analyze. First, you do not need to copy your data files into the folder with the script. Instead, you just input the path here. The path you get like this. You will go and just copy the address and input it here. Next, you have to input the usual data. For the calibration, we use 6 concentrations. In this case, I have 20 data points for each concentration. You can have different amount, it's okay. And channel number is 6 for this problematic probe. Here next, pay attention, it's important. This parameter is used to tell the script which files you want to analyze, because it can work both with calibration files and with detection. In case you want to see calibration, you choose one here. It's like yes in Boolean. In this case, yes, it is calibration I want to check. And so I chose 1. Next, you can choose whether you want, how you want to see the results. It can be 3D or 2D. In this case, I chose 2. It's pretty straightforward. So, next step is also important. You see, in the case of this probe and this calibration, we are supposing it doesn't have any peaks and valleys worth speaking about. So you input here 0. It tells the script that there is no peaks and valleys, and it should look only at the random points to see if there is some sensitivity which got undetected. So we will run the script after all the settings are made, and we'll see what it gives. So you can see a pretty interesting picture here, which is worth attention. You see that intensity changes uniformly across the first three concentrations. But then something happens at the fourth concentration. It can be that a particle got stuck on the probe or something like that. We cannot know. But this is indication that the probe deserves a second chance. And now I will look at the very same probe, just in different calibration. For this, we return to our script and go to the luckier concentration. Also copy its path and just input it here. And we leave everything the same. Also here we leave 0 to look at random points. It doesn't matter actually. And here are the results for the very same probe, for the very same channel, but different concentration, which is the lucky one. And you see that in reality the probe is really good. Remember, these are random points. And still, we have a very, very smooth gradation. Sometimes not very smooth, but you see that this is a signature of a really good probe. So it means we just saved time and saved the probe, which had a bad day, but now it's back in line and can be used. Next, we will see how we can use the very same script for the detection. For the example, I will use one of my detections. It has just two concentrations, but it's okay, even better to see the contrast. So, input in the path in the folder with detection here. Next, pay attention to adjust the parameters, because in my case here, it was only two concentrations. I have many data points for each, but let us leave it at 20. Channel number is again 6. I paid attention to use the same channel for the same probe. Calibration here, what you change. You change it for 0 because it's not a calibration, and it tells the script to use naming convention for detection files, like concentration, number, measurement number, and so on. Orientation also 2D, and again we will look at random points now. Click Run. And you can see very good contrast. So it's obvious. Here is the first concentration, which was PBS. And the second concentration, you can see it was concentration number 2. Contrast is pretty striking. But you remember, it is for random points. You actually can choose peaks to look at peaks, not just random points. But if a probe is good, I found out that the actual difference between the pictures for random points and the peaks are not so striking. So let us see how it looks like in this case. See, pretty much the same, but there was a minor mistake because there were no right valley, and therefore it didn't show this valley. So even for our good sensors, you can use 0 here as if there were no peaks, just to avoid possible discrepancies here. And now a brief point about the advanced settings. This is the next section. And I ask you not to change anything here unless you are 100% certain you want to do it. Because here basically you're just choosing the filter we're using to pre-process our signal. In this case, this one here gives the best contrast. If you feel comfortable with these settings, you can comment this and comment that, for example. If for some reason you want to analyze using this filter, click Run. And now you can see the differences. Yes. You also can see contrast, but it's not that good as with the default settings. So yes, you can use it if you want for some reason, but better stick to this. Since this script is qualitative, not quantitative, and you want to see if there is contrast or not. This is the end of the tutorial, and if you have any questions or suggestions, feel free to contact me anytime. Goodbye.